Hi friends, welcome to the Unit 4 Day 4 Notes. Example 1, rewriting expressions using logarithmic properties. So the goal here is to expand. Now, you can get really intense with this. You can expand some of these out to just insanely long expressions. That's not the goal here. The goal here is to know, kind of going back and forth between the two ideas, is using that properties of logs talked about in the previous video, what are some of the ways that I can write this? Now, the goal is going to be more so in this second part where we're going to express it as a single logarithm. Like that is going to be our end goal, is to take something that's multiple logs and turn it into a single logarithm. And by the way, I'm going to abbreviate logarithms into logs a lot. So here it says expand. We're not expanding it completely because you can get really ridiculous with how much some of these can be expanded. But really, I'm just kind of showcasing with the single operation or step. So here I have log base 7 of 8 times 6. So I want to turn this into an addition because I'm going to be using that first property on the previous page, this one here. Log base b of m times n. So what we're doing is the same base, log base b of m plus log base b of n. So log base, same base here. So log base 7 of 8 plus log base 7 of 6. You can continue with this. I am purposefully stopping here. You can go farther. 8 could be rewritten as 2 to the third power, or 2 times 2 times 2. Log base 7 of 6 can be written with 2 times 3, and you can continue to expand these. I just want to showcase that because it's not, when we say that we're wanting to expand these, we're not expanding these completely. Notice that I didn't use the word completely. So log base 6 of 12 fifths is the same as log base 6 of 12 minus log base 6 of 5. Now we're getting into log base 2 of the cubed root of 9. I just want to showcase that this is the same as log base 2 of 9 to the 1/3 power. Now, why would I be talking about 9 to the 1/3 power? Well, this property is actually using the power property. Now, remember that when we raise something to the power, then we can bring it out in front. So this is the same as 1/3 times log base 2 of 9. Now, I note that because this is the same as log base 2 of 9 divided by 3. So this can get a little bit hairy if you're not really confident again with those properties. So talking again, I'm hammering these properties as much as possible. You got to spend some time with those properties to feel confident. This, we have a few different things going on here. I have this part here divided by all of this here. So when we talk about going through and simplifying this, if I have log base b of r, that kind of looks like 6. b of r plus log base b of s squared. Again, we'll talk about s squared here shortly. Plus log base b of t. Now, I'm subtracting all of these, u cubed and v to the 5th. So I'm going to do minus. Now, if you want to think about it in terms of parentheses, and then you're going to distribute the parentheses, that's fine. But really, it's minus log base b of u cubed minus, again, because the v to the 5th is in the denominator, log base b of v to the 5th. Now, again, there is more steps you can do with these. I can bring down the 2 to multiply out. Like I could do log base b of r plus 2 times log base b of s plus log base b of t minus 3 times log base b of u minus 5 log base b of v. So, and note, we can continue going on with some of these. I'm going to stop here just to kind of showcase this is what's going on. For this next one, this is r to the 3/5 power, just writing that off to the side here. So this is going to be log. So pulling out that 3/5 in front, so that's going to be 3/5 times log base a of r. So what this is saying is 3 times log base a of r divided by 5. So when you see a log that's divided by a single number, you know that whatever base and whatever that of value, finding the log of, that's to that power, raised to that power as in the reciprocal. So this is r to the 3/5. Then here there's a lot of things going on. This is to the mth root, which another way of thinking about this is that's all of this here, the r to the 3rd power, r cubed, that's that s squared, and that t to the 4th, that's all of this raised to the 1 over mth power. So a way of thinking about this as we go through is log. So let's start with the r first. So 3 times log base a of r plus 2, because of the squared, log base a of s minus 4 log base a of t. Now all of this is being multiplied by 1 over m, or I can think about all of this being divided by m. So there's some expansion that we just did with this one. Again, I'm telling you, knowing how to expand things is useful because most often what we want to do is we want to take multiple logs and we want to express it as a single log because then we could use it to solve. So again, our goal here is to get it to a point where we can solve. So log base 4 of x minus log base 4 of y plus log base 4 of z is equal to log base 4 of x over y times z. So this is x times z divided by y. This is different. I'm showcasing this is different than dividing the whole thing by that. And these two are very different. So this is just xz over y. This is log base 4 of xz over y, as opposed to just dividing the entire thing log included by that. For this next one, again, we're writing it as a single logarithm. So what we can do is we can write, I'm going to kind of showcase a few of the steps here along. So log base b of r to the 4th minus log base b of x to the 5th. And then now combining it into a single log base b of r to the 4th divided by x to the 5th. Now for this last one, hoo-wee! Got a lot of things going on here. So what we're going to do is we're going to take, again, all of these have the same base. And because they have the same base, we can use these properties. So be careful. Note that all of these have the same base as we're going through. So this is log base a of equal signs x to the 1/3 plus log base a of y to the 2/3 minus log base a of xy. So now combining this, so we have log base a of x to the 1/3 plus, so that's going to be multiplied, y to the 2/3 minus, so we're dividing by x and y. Note that our x and y in our denominator is rationalized because they have positive integer exponents. So we are good with this. And we've condensed all of these to a single logarithm. Join me in the next video as we go over example 2 and where we start evaluating, finding the values of logarithms. Have a fantastic day.